Welcome to this multi-part AWR video series. In this series, we will look at PCB layout-driven design with VSS. One of the challenges in doing PCB design is that very often microwave measurements are not used for the PCB specifications. This can be true when doing phone boards or doing Wi-Fi designs or doing signal integrity designs. The specifications can be defined for EVM, bit error rate, or ACPR. But most interconnect analysis tools are not tied into system simulation, and in fact most tools geared towards high-speed design simulate microwave properties like gain, noise figure, P1dB. What we'd really like to do is to be able to move a trace and see a system parameter like EVM change. The solution is the AWR design environment. AWR DE integrates VSS, a system simulation tool, Microwave Office for integrated PCB design and layout, ACE for fast interconnect analysis at gigahertz frequencies. It's used as an interconnect analysis tool in this flow. Axiom for high capacity, highly accurate EM analysis. In this flow, it's used as an interconnect verification tool. All the tools integrate into a single flow for PCB design. In general, in this flow, we will take a look at a layered, iterated design approach. We'll be concerned with design hierarchy, and we will build up the design in a hierarchical fashion. We'll start by component modeling using Microwave Office, and then do a little bit of RF design to make sure that our components make sense, that they are able to reproduce the data sheets that represent these parts, and we'll do that in Microwave Office. But ultimately we will do all of our simulation in VSS because this is where our system is specified. And in this example we'll look very closely at EVM for our design. We'll also increase design complexity very slowly. Again, we'll start with a single element and build up a model for it. After we have a model for each one of our components on our board, we'll do an ideal design, and in this ideal design we'll just cascade each component into 50 ohms, assuming that the interconnects are perfect and ideal. Finally, we will add the design in with interconnects and look at the effects, first by using ACE analysis to look at the design of the interconnects so we can very quickly adjust the interconnects and make changes to improve the performance of the design. And then finally, we will use Axiom simulation to verify that our design is correct, with Axiom being a very, very accurate EM solver. In step 1, we'll look at component modeling. We'll model baluns, switches, and a power amplifier chip or packaged part based on manufacturer specifications. We will develop Microwave Office models and then test that the model works in VSS by using a LinS or NLS model or other appropriate simulation-based model that takes Microwave Office circuits or Microwave Office models and brings them into VSS, automatically generating the behavioral model necessary for the system simulation. In step 2, we will assemble the ideal PCB. Here we will use these component models only. We'll not look at interconnects unless perhaps we want to include a bit of a packaging effect for some of these parts inside of their packages. This will allow us to estimate the final PCB performance using VSS, and we will only use Microwave Office models developed in step 1. We won't add any additional models at this point in time in this step of the flow. In step 3, we'll add the interconnects. Where we know that we're very, very concerned with signal path performance, we will explicitly use mtrace, which is a routable microstrip line, or mctrace, which is a routable microstrip curve line for our signal path. Where we know we have coupled lines, we'll use a coupled line model as well to explicitly capture these couplings. One good example of this is the pad stacks that come off of component parts. We know that those pads are coupled to each other, so we might as well use the couple line and very early in our design flow capture the interconnect coupling. Everywhere else we will use iNets, and this is a great way to route lines on a PC board that we want to look at later on in our design process. So we'll use iNets for control lines. We'll actually use iNets for some of the signal path as well. During the design part of our flow, we will use ACE to analyze them, and during the verification flow we will use Axiom, combining all of these lines together, the mtrace and the coupled line models, as well as the iNets. In step 4, we will analyze all of these interconnects that we've routed with ACE. This gives us a very fast, somewhat accurate analysis. Not as accurate as EM, but very, very accurate nonetheless. This will allow us to quickly tune and optimize lines to improve performance. We will then be able to simulate directly in VSS by incorporating these with our microwave office models. VSS will automatically take the microwave office description of these lines and our components and create behavioral models for us in VSS. And this will directly use the ACE analysis of our interconnects in the VSS simulation so that our EVM, our bit error rate, our ACPR will include interconnect effects directly, and we can very easily change those interconnects to optimize and tune our design in VSS. In step 5, we will do a final verification with Axiom. This will take a little bit longer than ACE and will give us a highly accurate simulation and confirm our ACE results, which we'll again be able to simulate in VSS to look at our overall system performance. In summary, PCB design flows can be full of conflicts. We want to look at specifications at the system level, but we need to take into account our interconnects and critical design decisions at the layout or physical level. The AWR design environment integrates the whole flow. It allows us to do systems design, component level modeling and simulation, and incorporate this with PCB layout so that we can do both interconnect analysis and verification. And because there's a whole suite of EM solvers inside the AWR design environment, we can also co-design our antennas and simulate them with the entire PCB design. If you'd like more information on this design flow, I encourage you to look at the other AWR TV videos in this series, or if you have more questions, go to the AWR website or contact your AWR sales professional.